The objective of this lab was to observe an object traveling at a constant velocity and create a position versus time graph and create a computational model of the object's motion and compare the two. As a result of this lab, a disparity between the data points was observed, which led me to investigate how and why this disparity occurred. For the experiment, I used a 3.5-ounce container of VapoRub. For my system, I rolled the VapoRub across the carpeted floor along a 12-inch ruler to measure the distance. For my experiment, I chose for the coordinate axis to be centered in the middle of the VapoRub container. I then used this code to generate a computer model of the experiment. This code is based on Newton's second law, also known as the momentum principle. Newton's second law was the base of this lab because it allows us to predict an object's motion. This law states that net force is equal to the change in momentum, delta p, over the change in time, delta t. We know that this formula for momentum is mass times change in velocity, and that delta v is equal to v final minus v initial. Thus, we can derive the equation for final velocity, v initial plus net force divided by mass times delta t. Because the velocity in this lab is constant, we know that v final is equal to v initial, therefore making delta v 0. Since delta v is 0, the net force is 0 as well. From this conclusion came the updated formula for position, r final equals r initial plus v times delta t. After uploading my video on Tracker, I was able to gather the initial conditions: start time, initial position, and final time. I calculated v initial with the first two data points and their corresponding timestamps. I then substituted the mass of the VapoRub and the numbers from the updated position formula and the updated velocity formula from Newton's second law into the code so the computational model would accurately represent the experiment. With this data and the conclusion that net force is 0, this is the visual representation in the graph that the code presented. By comparing the graphs of both the experiment and the computer model, you can see that the graph for the experiment has a slight but still differing initial position. More importantly, we can see that the model data overshoots the experimental data. As the time increases, the discrepancy between the graphs also increases. This could be for a multitude of reasons. We can see that as my object was moving, it wasn't moving in a straight line along the axis. Because the container strayed from the x-axis, the travel position was less than predicted. The discrepancy could also be because I used the first two data points for my initial velocity instead of the average velocity, which would have given a more accurate velocity. Choosing average velocity would have lessened the disparity between the graphs. This is because we used Newton's second law to assume there is no net force, meaning that the initial velocity was equal to the final velocity. If I redid the experiment but flipped the coordinate axis so the object moved in the negative x direction, the only thing to change would be the direction of the motion. The initial position and velocity would become negative. The time interval would remain the same as well as a change in time, position, and therefore velocity. I cannot safely say how many forces act on the container to add up to 0 net force because of the factors that I don't know. I don't know about air resistance, or if the floor was exactly level, or the friction force on the carpet, which was probably substantial. All I can safely say is that there were many surrounding forces acting on my object that represents my system. Thank you.